Hello, Unicorn099. This is T-Stat Tech here. I'm making this video in response to your video response to my text comments. First, I want to start off by saying, I guess there's two comments that you had commented about mine. First thing I want to start off with is the price comment. I understand that was just a hypothetical situation, and I was probably out of line by saying that was ridiculous. So that's out of the way. Next thing is about using surfaces for moving air or air diffusion into a room. If you've made a comment that was ridiculous or something to that effect. I mentioned in my comment in response to that about ACCA Manual T, and some of this you're probably, or most of it, you're going to be familiar with. But with my videos, this happens to be my first video with a decent camera. I tried to use my cell phone camera in the past, and it just turned out bad. So now I've got a decent camera, and I'm going to make some videos to help maybe the new guys getting in the trade. Some of this information should be readily available, but isn't. You've got to go search this stuff out, and I've spent 20 years in the trade, and over time have went out and found this stuff for myself. Should be at your distributor, probably isn't. Should be at your place of employment, probably isn't. I'm going to start off my first few videos discussing just books and things that I use that really you have to have. If you don't have this information, you really don't know what you're doing when it comes to designing systems and checking systems. Very pertinent information. Mentioned Manual T, talking about moving air over surfaces. It's describing moving air, I don't know if you can see that, moving air over a ceiling, and talks about extending the throw by doing this. And you may ask, well, why would you want to do that? You had mentioned that you'd set your floor registers out 12 inches away from the wall. Well, I understand that you're using a bolometer, and your bolometer is 2 foot square, and you want to center it up under the cone so you get an accurate reading. The reason I don't set my registers out that far is because, for one, people don't like to look at registers. Two, I do a lot of heat pumps and geo, and I don't want cool air. It's air coming out of the register, and the heating mode is warmer than the room air temperature, so it's warming the space, but colder than the body temperature. So if it's at any substantial velocity at all, they're going to feel a draft. So the way to get around that is to keep it out of the occupied zones. And you can use surfaces to move air, and it's not conditioning drywall per se. It's using that space using that surface to move the air for you. And it's just basically like a one-sided duct, if you want to think of it that way. And you can move air up the wall, and they recommend that use enough throw to strike the ceiling so that you can start carrying it across the ceiling. Now, that's another thing to do with a high sidewall is to put the register as close to the ceiling as possible and let the air move across the ceiling. I'm looking for an illustration here that shows that you get a 30% increase in throw by doing that. And you also, there it is, that air also slows down and spreads further, not only straight out but in all directions, and that air will fall off the ceiling at a rate slower than 50 feet per minute, which is going to be around the edge of your perception, 25 to 50 feet per minute. Skin can perceive that. So one of the things I like to do with my duct systems, I don't want people to feel uncomfortable by air blowing on them. I don't want them to hear of my systems. And ductwork can be difficult to design, and you got to have the right tools. You got to have, if you're doing residential, you got to have Manual D, it's an old copy. Manual D, the new copy. The old copy The old version gives you tables in the appendix to give you equivalent lengths of different fittings, and you're going to find out real fast that you run out of airflow on a residential system because you have to use the fan that you're allotted with. Yeah, you might get to choose between a 3-ton and a 4-ton fan in a given furnace. You might even choose an ECM motor, which is going to help you out help you out in more ways than one. But you're going to find out real quick that by adding up these equivalent lengths, that you run out of fan real fast. I'll go into more detail on this in another video, but the new one, I know it's pricey. It's things like $60. You gotta go to their site to buy it. Might be some other sites you can find it on, but they've added some new things to it, like more information about flex duct, information about trading. See, on the old version, it was all rated at one given velocity, typically 700 feet per minute for return and 900 feet per minute for supply fittings. Well, so your equivalent lengths are at worst case scenario. The new version gives you a way in the appendix to gain credit for more efficient duct design. So if you can get your velocities down, then the penalties won't be as great. So it's a real trading back and forth game when you're designing residential systems. You're going to find out that commercial systems are easier to design because you get to pick the fan out after you've designed out the duct, and then you can even change motors and shivs, and you can get pretty much whatever flow you want out of a rooftop unit, package unit. Another tool that I want to talk about is this is the only ductulator you should be using. Again, should be at your distributor place employment. Probably isn't. You're gonna have to order it. Expensive, like $35-40, but it's the only one that does flex. Only one that does ductboard, does duct liner. Just a great tool. Can't live without it. You would be really surprised the difference between a flex duct and a galvanized sheet metal duct. And this is flex duct pulled tight. You've got to pull your flex duct tight. Don't snake it around stuff and pinch it off and make elbows with the flex. That's not what it's intended to do. Flex has its purposes, just as ductboard has its purposes. I don't really like either one. I force myself to use them sometimes. I'll put 5 foot of flex on about every run I do just to kill noise. Sometimes you get some noise attenuation in a duct system from the blower, and it's a real easy way to deal with it. And if you use it correctly, you shouldn't have any trouble with flex, but I see a lot of flex put in wrong. Other things I want to get to in later videos, I want to show what sort of tools I use, what I've found, and one thing you've got to have, I just made my own, you can find it on the internet, I don't remember the address right now, but you've got to get a gamma venting table. If you're dealing with 80% furnaces, natural draft water heaters, combining them, anytime you're using a flue, other than a 90% plus furnace where the instructions are there in the manual for you, you've got to have that information. I see flues improperly installed all the time. Water heater flues that are teed in with 80% furnaces, water heaters 20 feet away, and the 3-inch diverter comes out of it, so they just use a 3-inch pipe regardless, and they just think, well, the 4-inch come out of the furnace, we'll use to 5, regardless of rise and run of each of the appliances. Sometimes you're going to find that you need to increase, from a 3 to a 4 on a water heater. You're going to maybe need to run double wall all the way back to that appliance. But very important, because it may not backdraft while you're there, but if it backdrafts at all, you could find yourself in real trouble, and that's something you don't want to happen. So you got to look at these things. I think that's about covered it for my first video, and Unicorn099, I'm going to miss your HVAC videos. Good luck in the IT field, everything you do. And hopefully I can put together some better videos in the future. This is just kind of ad-lib, got the camera, wanted to play with it. So this is it. Thanks guys, hope you enjoyed it. Bye.